Hi everyone, welcome to another tutorial session from Bhutan Tech Community. This tutorial is on version control systems, specifically Git using GitHub. We have a demo at the end, so make sure you stick around. Developers work with a lot of files and we frequently share them with our teammates. Let's say we are using portable drives to maintain our versions. User 1 here is sharing files with user 2 and 3. This can become a big mess as the project grows. It becomes hard to track who made the changes and when and why these changes were made. Let's see what happens with the version control system. Here, everyone can update the files or get the updated files at any time. A version control system maintains all the different versions separately in the same repository. For each change, it also tracks when it was changed and who made that change. So user 1 and 2 can work on version 1 and user 3 can work on version 2 or a different feature at the same time. This is not limited to just few users. Everyone who has access to this repository can make changes. This is what all version control systems are based on, but they are much more, as you will see. Let's see why we should use a version control system. We can compare files, review changes, track work progress, maintain multiple versions in the same repository, break our app down into smaller parts, and you can focus on the real problem because we are supposed to be working on the app, not logging file changes. How do we do it? Let's go to the drawing board and see how Git works. When we start a project, we always begin from the first set of files. Let's group these files and let's call it master. The dots represent the same group at a particular point in time. Over time, new files will be added to this group or their contents may be changed. At any point in time, with the version control system, you can create a branch from that group. It will have all the file changes from the parent group, say master in our case, and you can add new files to this new group or change the contents of the files from master. I'm calling my new group feature login. Any group can be a parent, so you can create branches at will. You can see we have two branches for feature homepage, feature header and feature footer. When you want to release your version, you can merge all the required changes from the sub-branches to the main branch. We can ship out the final version from master or branch. Here we are merging all our files back to master, which is the branch where all our changes or updates will be reflected. The latest version of master, which is the last green dot, should have all the updated files. If you have noticed, the changes for feature login is not merged. We can have many branches like this one, which will or will not be shipped with the final version. Let's say this system of parent and branch links exists on a remote repository. In our case, this will be from GitHub. Version control lets us copy and maintain the same system of links on our local machine. If we want the latest copy of feature header branch, we can pull it from remote. Similarly, if you want to update your changes to remote, you just need to push it. Also, we do not make changes at one time. Changes are broken down into smaller chunks called commits. To update the changes from your commit to remote, you just need to push them to the same branch on remote after making your commit. One more thing, you can actually save your work temporarily without pushing it, which is called stashing. This is useful when you have to work on a new branch immediately but you want to save your changes for the previous branch without pushing it. You can apply the changes to your branch from the stash whenever you need it. There are a lot of things we can do with Git, but these are the most common things we use. You can refer to the documentation on their page if you're looking for a specific functionality. For now, let's see an example. To install Git, go to their site and get the recommended version for your operating system. You can use an installer or the terminal to complete your setup. If you are a Windows user coming from Linux, you can also install Git Bash and use the same commands from a Linux system on Windows. When you are done setting up Git, go to GitHub and create a new account and sign in. You will be directed to the home page after you sign in. Click on New to create a new repository. Let's give our repository a name. We can skip the description and let's make it private. Check the initialize with readme and click on Create Repository. Our repository has been created. You can see the name of the repository shown in the readme file here. GitHub has already made a commit for us. Let's see the details. This commit is for initializing the repository. You can see when this commit was made and who made it, and also has a unique ID tag to it. Let's go back and see what else we can find. We have one branch, 0 packages and 0 releases. If you click on branch, GitHub has created a branch called master. This is the base branch. Now we can start adding new branches. But before that, let's add a collaborator to this project. Click on Settings and go to Manage Access. I will invite a user to contribute to this project. An invitation will be sent to this user. After the invitation is accepted, this user can manage our repository and get updates on changes. Let's go back to the Code tab and add a new branch. We will name it Feature Marble and click Create. Next, we will create a new file. This is a simple text file. Let's put in some content. Scroll down and enter a commit message. This will be helpful later to understand why you made this particular change. We can choose to take this change to a new branch, but I will keep it on the same branch. We also need to name our file and click on Commit. Now we can see our file here in the file tree or explorer. Let's quickly add a new branch and add a new file to it in the same way. At the top, you'll see a button called Compare and Pull Request. Pull requests are created whenever we want to merge our changes on a branch to another branch. It is a request because it can be reviewed by your teammates first, and you can also resolve any conflicts if they exist. Let's click on Compare and then create a pull request. Our pull request is created and it's now checking if we can actually send the changes on Feature Marble branch to master. Like it says here, you can integrate tools here for checks. You can decline this pull request by clicking on the Close button. Go to Commits tab to see how many commits are there on this merging branch, Feature Marble, and we can also see file changes here. This will show the difference between branch, master, and Feature Marble. So here we have added a new file called Marble. That should be the only difference. We also have a file called readme.md, but it was not changed, so it is not reflected here. Now let's see the repository as the collaborator we assigned few minutes ago. We are on the master branch and we can see the feature DC branch was created. Let's switch to feature DC branch, make some changes to the DC file and make a commit. You can see now our commit is reflected on this branch. Let's check out the pull request. There is one open or active pull request called adding new heroes. Let's go in and see the details. We can go to files changed and comment on a specific line. We can add it as a comment, but for now let's start a review. We can click on finish your review and approve it. You can see we have one approval. Let's go ahead and merge it. The changes on Feature Marble is merged to master. Now our new file Marble is on master. When we are building our app, we will need to test it. So we usually make our changes on our local machine. We won't be changing our files using online GitHub interface very often. So let's see how we do it from our local machine. You can choose to download the GitHub app on your computer and make the changes in the same way we did using the online interface, but we will look at a different approach using our terminal. Go to your repository and click on Clone or Download. It should give you a link. We will use this link to set up the same repository on our computer locally. Also, I'm using Mac OS, so if you are using Windows, you might want to look up some terminal commands, especially to navigate your file system. Open your terminal and enter git ---- version to see if we have Git installed on our machine. You can also use git ---- help to see all the commands we can use with Git with all the descriptions for the command. The text or option following the git command is called a flag. Now type git clone and paste the copied link from your repository. Here Git will ask for your GitHub credentials and also check your access to the repository. I've already logged into my account, so I can skip this step. Now it will download all the files from our remote repository. If you type ls, you can see the superheroes directory. Type cd superheroes to enter this directory and you can see we are on master branch. You can see all the files from remote branch are here. If we enter git remote -v, we see where our local repository is pointing or linked to. It also has an alias assigned to it which is named origin. So if we want to use the remote link with any of our git commands or flags, we can use origin. Now let's make some changes to our master branch. By the way, it's not recommended to work directly on master. It's always better to make your changes on a separate branch. For now, let's make an exception. I have my repository open in Atom. Let's add a new file called index.js. Atom also comes with Git plugins already set up. On the bottom right corner, if you click on Git, we can see our changes. If your file does not exist on remote, it is untracked. If it is there, it is tracked. And there are two types of tracked files, staged and unstaged. If it is staged, that means it will be sent to remote if you choose to commit it. Unstaged changes will not be updated to remote. If we go to our terminal and enter git status, we will see the changes. We can also use git diff to compare the same branch on remote and local. It is marked as untracked by Git. Let's keep it that way for now and let's switch our branch. Let's add a file and send it to remote. We already have our untracked file index.js. Enter git add index.js to stage it. Enter git commit -m to add index file. Remember, we added a description for our commit on our online interface. This will do the same thing. The -m flag is for message. Now our commit is created. You can also see a unique ID has been assigned to it. It also shows some details on the changes. However, this commit exists only on our local repository. We can find out if we enter git status. Our local branch has one extra commit compared to the same remote branch. It is also suggesting to push it to remote, so let's do that. Now we can do git push origin feature marvel to send this commit to remote. One thing you will notice here is we use the origin alias for our remote repository link. We can use this alias while we are working with our remote without git commands. We can have multiple aliases with multiple instances of the same repository, which may or may not be configured differently. Now if we go to GitHub, we should see our changes on the branch feature marvel. Our new file index.js has been added to remote. When we do not want to commit, file or track changes for a file, we use Git Ignore. Let's see how we can do this. Let's create a new file called config.js. If you check status, we see that Git is tracking this file. Let's add a new .gitignore file to our repository using the echo command. Config.js is our content and we use the double forward arrow to insert it into our .gitignore file. Now the .gitignore file is ready. We can add the names of all the files we do not want Git to track to this file. Let's see the status once again. Now Git is not tracking our config.js file. This will only work if the file is untracked. If you add a tracked file to .gitignore, it will still track the file. If this happens, a quick workaround is to clear your Git cache. Now let's see another way to set up our repository using git init command. Create a new directory called superheroes, navigate to this directory. Enter git init. Now we need to add a remote repository to it. You can enter git remote -v to check if we have any existing remotes added. Enter git remote alias your repository link to add a repository. Now if you type git remote -v, you should see we have our remote setup. However, we still need to pull it to get all the files from remote master. When we try to pull from an alias called origin, it does not work as we have set up our repository alias as source. When we do git pull source master, it should work. Now we can resume our work on this repository. Let's see how we can stash our work. We will create a file called index.js. Say we want to switch to another branch immediately and save our work on this branch temporarily. We need to save it to stash. Let's add our file and enter git stash to send it to our stash. Now if we check the status, we do not have any changes. Enter git stash list to check how many groups of changes are stashed. I will not switch my branch for this demo. Instead, let's say I have committed all the changes from the other branch and I have switched back to the branch where I created the stash from. Now I can enter git stash apply stash id to apply the changes back to this branch. For now we will use git stash pop, which will apply the changes from the latest stash to this branch. If we check status, we should be back on track with our index.js file. Some other things we can use are Git Lock, which shows all the commit details for a branch. We can also add flags to Git Lock and get more detailed views of our commit history. So this is how we use Git for our version control system. Now you can go ahead and set up your own repository, start creating branches, and make commits. Thanks for watching.